and welcome back to another exciting day of P-Flix Math with Mrs. Dennis. Are you ready for another excellent day of teaching and learning today? Great, so let's dive into another exciting day of P-Flix Math. So remember, we've been learning all about fractions, and a great tool to learn more about fractions is using slices of pizza. So let's take a closer look at our objective for today. So our objective says I can generate simple equivalent fractions by using fraction models. So today, our goal is to look closely at equivalent fractions and look at fraction models to determine if fractions are equivalent. So before we get started, we have to build our fact fluency, especially in multiplication, because when we build our fact fluency, it just makes us that much better mathematicians, because that means we know our facts very quickly. So today I'm going to teach you a new exciting trick, but this time I'm going to show you a trick to help you with your 11 times tables. Are you ready? Oh my goodness. So let's take a closer look at our 11 times tables trick. So when you are multiplying single digit numbers by 11, you just repeat the digit twice. I know, right? It's hard to believe, but it's just that simple. When you multiply a single digit number like 5 by 11, you just repeat the digit twice. So 5 times 11 is 55. So in your notebook or on your whiteboard, let's practice this trick together. In your notebook or on your whiteboard, I want you to write the numbers 1 through 9. So you're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. You done? Okay, great. Then I just want you to write the numbers 1 through 9 again, right next to 1 through 9 that you already written in your notebook or on your whiteboard. So then I want you to write 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom! Right there, that is our 11 times tables. So let's take a closer look. 1 times 11 is 11. 2 times 11 is 22. 3 times 11 is 33. 4 times 11 is 44. All we do is repeat the digit that we are multiplying by twice. So let me ask you, what is 6 times 11? Great, 66. What is 4 times 11? You got it, 44. What is 9 times 11? You got it, 99. All you do is repeat the digit twice. So now that we practice our little trick, Miss Dennis is going to give you a few multiplication problems, and I want to see how well you know your 11 times tables. Are you ready? I can't hear you. Are you ready? Great. Here, let's get a little bit of practice with our 11 times tables. So let's try these problems here. What is 11 times 3? You got it, 33, because you repeat the single digit twice. What about 11 times 5? Excellent, 55. What about 11 times 7? You got it, 77. What about 11 times 9? 99. Excellent job. And this is a great trick that you can use every time you have to multiply by 11. Isn't math the best? There's so many tricks that we can use to help us become better mathematicians. So let's look back at our objective for today. Our objective says I can generate simple equivalent fractions by using fraction models. So again, what is a fraction? Well, a fraction is part of a whole, right? Fractions are part of a whole number or a whole object. So when we look at equivalent fractions, equivalent, you hear that word, equivalent. Equal, absolutely. And when something is equal, that means it is the same. So when you look at equivalent fractions, they are fractions that are the same shaded size or cover of space of a whole number or on the same point on a number line. So if we look at our fraction models here, we see that 1/2 of this whole circle is shaded, which is equivalent to 2 out of 4 parts shaded because it has the same amount of the shaded area, which is equivalent or equal to 4 out of 8 parts because it still has half of the circle shaded. So if we notice, we see this part is shaded, this part is shaded, and this half is shaded. So that means all of these fractions are equal. So 1/2 is equal to 2/4, which is equal to 4/8. So this is how you look to see if fractions are equivalent in a figure. But on a number line, right, we know that if the point is on the same part of the number line, then the fractions are equivalent or they are equal. So 1/2 is the same thing as 2/4, which is the same thing as 4/8 because it's on the same part of the number line. So let's take a closer look at our strategy for today. We know equivalent means yes, equal. And we know that two fractions are equivalent if they are the same size or on the same point of a number line. So are these two fractions equivalent? Well, let's take a look. So we know, and I'm just going to move myself over a bit here. So if we look at our figure closely, they're asking us is 2/3 because there's 2 out of 3 parts, right? Equal to 4 out of 6 parts. So are these two fractions the same? Well, we know that if equivalent fractions take up the same amount of shaded area, then we know they are equivalent. So let's look at 2/3 and 4/6. Well, if we notice, it looks like they have the same amount that is unshaded and shaded. So is 2/3 equivalent or equal to 4/6? Well, yes. And Miss Dennis is going to move herself up a bit so we can see very closely. Well, yes, we know that they are equivalent because they have the same amount of shaded area. So let's look closely at another figure. Is 1/2 equivalent to 2/4? Remember, equivalent means equal. So is 1/2 the same thing as 2/4? We know that if two fractions are equivalent, they have the same amount of shaded area, or they're on a same point of a number line. But because our objective today focuses on the figures and not a number line, we're looking to see if is the shaded amount the same in both figures, in both shapes. So are these two fractions equivalent? Well, let's take a closer look. We see that half of this circle is shaded, and even though this is 2 out of 4 parts, it still looks like half of the circle is shaded. So is 1/2 equal or equivalent to 2/4? Yes, it is because they have the same amount that is shaded in both figures. Now let's take the next look at the next two figures below. So remember, we are thinking, are these two figures equivalent? So remember, equivalent we talked about is equal. And you know two fractions are equivalent if they are the same size and they take up the same amount of space in a figure, or if they're on the same point of a number line. And so my question is, are these two fractions equivalent? Are 1 1/5 or is 1/5 equal to 3/4? Well, let's look at the figure very closely. If we see 1 out of 5 parts are shaded, but if we look at the other figure, this is not the same, right? This looks like a way bigger portion of it is shaded than this. So we know, no, 1/5 is not equivalent to 3/4 because they do not take up the same amount of space. So now that we looked at some figures closely, let's try this now with a word problem. So remember, our objective is to generate simple equivalent fractions by using fraction models. So Mrs. Cruz Gomez and Mrs. Hernandez ordered 2 pizza pies. Mrs. Cruz Gomez ate 4/8 of a pizza, and Mrs. Hernandez ate 3/6 of her pizza. Did they eat the same amount of pizza? Well, I know when I solve a word problem, the first thing I'm going to do is I'm going to draw a picture so I can visually see what the problem is asking me. So first I'm going to draw, well, I know it's Mrs. Cruz Gomez and Mrs. Hernandez, and they both order pizza. So I know I'm going to draw these 2 pizzas. Well, let's first start with Mrs. Cruz Gomez. Well, first I'm going to draw a pizza, and I'm going to cut it into 8 slices. I'm going to have 8 parts because I know she ate 4/8 of a pizza. So let's just check to make sure there's 4/8. There's 1, 2, 3, 4, 5, 6, 7, 8 parts of this pizza. And if we notice, 4 of them are not there, right? Because she ate 4/8. So Mrs. Cruz Gomez ate 4/8 of her pizza. Now let's look at Mrs. Hernandez. I'm going to draw a pizza that's broken into 6 parts, right? Because of that denominator, that bottom number is 6. So let's double check to make sure this is 6 parts. There's 1, 2, 3, 4, 5, 6 parts. And Mrs. Hernandez ate 3/6 of her pizza. So we know she ate 3/6. Now let's look at the figures very closely. Did they eat the same amount of pizza? Well, let's look. It looks like Mrs. Hernandez ate half of her pizza, and it looks like Mrs. Cruz Gomez ate half of her pizza. Therefore, yes, they are equivalent. Mrs. Cruz Gomez and Mrs. Hernandez ate the same amount of pizza because even though Mrs. Cruz Gomez had more slices of pizza than Mrs. Hernandez, if we see the amount that they both ate, there is the same amount that both of them ate. So they ate the same amount of pizza. Isn't a picture worth 1,000 words? And when we draw pictures to help us, it makes things more clear and it really helps us solve our problems. So now it's your turn. Miss Dennis wants you to make sure you have your notebook and your whiteboard because I want you to work on the next few problems together. And you're going to do just like how we did together. And by the end of the video, we are going to check our work. So let's look at this word problem that I want you to work on. It says it's field day at Oakside. The school cafeteria ordered pizza for each class. Mrs. Curry's class ate half of their pizza, and Mrs. Sampaio's class ate 2/4 of their pizza. Which class ate the most pizza? So I want you to pause the video here and make sure you work out the problem. And I want you to think about, well, what are the numbers? What is the question asking me? And draw a picture to help you figure it out. And when you come back, we will check our answers together. Okay, scholars, have a good time solving this word problem. Okay, welcome back. Let's go over this problem together. So, remember our objective, right? We are going to simply generate simple equivalent fractions by using fraction models. So it's field day at Oakside, and the school cafeteria ordered pizza for each class. Mrs. Curry's class ate half of their pizza, Mrs. Sampeo's class ate 2/4 of their pizza. Which class ate the most pizza? Well, first I'm going to draw a picture. Well, I know that Mrs. Sampeo's class ate 2/4 of their pizza. So I'm going to draw a pizza pie. And remember, you're double checking your work. So we drew a pizza pie, and in the pizza pie, we broke it into 4 pieces. And we know that 2 out of the 4 pieces are gone. That's how much the class ate. And now I'm going to draw a picture of Mrs. Curry's class having a pizza pie that was broken into halves, and 1 out of the 2 pieces are gone. So now we have to look. Are these 2 fractions equivalent? Did both classes eat the same amount of pizza? Well, yes, they did. Both classes, even though they were broken into different parts, ate the same amount of pizza. They both still look like they ate half the pizza. So both classes ate the same amount of pizza. How did you do? Great job. I am so proud of you. So now I want you to work on the next few problems in your notebook. So here's another problem that I would like for you to work on. Write the equivalent fraction for each of the models below. How do you know that they are equivalent? So if we look at this model here, I want you to write the fraction for this figure. And then I want you to write the fraction for this figure. And then I want you to think about and tell Miss Dennis, how do you know these fractions are equivalent? If they are equivalent, how do you know? Okay, so pause the video here, and I want you to write the equivalent fraction for each of these models below. Okay, great. So I'm not going to show you the answer just yet because I want you to work on another problem. So let's look at the next problem Ms. Dennis wants you to work on in your notebook. So now this problem says, write the equivalent fraction for each of the models below. And how do you know it's equivalent? So it's the same thing like what you did with the problem before. I want you to write the fraction for this model, write the fraction for this model, and I want you to write the fraction for this model. And then I would like for you to tell me, are these fractions equivalent? Do they have an equal amount of the shaded area? And how do you know that they are the same? So I hope you pause the video here because I'm not going to show you the answer until the very end. So make sure you pause the video so that way when you come back, we can check our work together. Okay, scholars, welcome back. Before I reveal the answer to this, I want you to try one more problem in your notebook. So let's look at this one together as well. I want you to write the fraction of each of the models below. So you're going to tell me the fraction of this one, which it looks like it's what? It is good. There's 3. I want you to look at the shaded area. So there is 3 out of 4 parts total. So this fraction is going to be 3/4. Okay? And so here's an example of what I would like for you to do. So then I want you to tell me the fraction of this one. I want you to tell me the fraction of this one. I want you to tell me the fraction of this one. And then I want you to tell me the fraction of this one. And I want you to put the shaded area in the numerator, okay? And the parts in the denominator. And then after you tell me each of the fractions, there are 2 of these fractions that are equivalent. Which 2 are equivalent? Okay? Okay, so pause the video here, and then at the end, I'm going to show you the answer for all 3 problems, and we'll check our work together. Okay, great. Okay, scholars, so now let's go back and check our work. So we know that in the shaded part, there is 1, 2 shaded out of 1, 2, 3 parts total. And here there is 1, 2, 3, 4 shaded out of 1, 2, 3, 4, 5, 6 total. So these fractions are equivalent. And how do we know? Because they have an equal amount of the shaded area. If we look closely, this shaded area is the same amount as this one here. So we know that 2/3 is equivalent to 4/6. So now let's look at our next one. We know that there is 1 shaded out of 1, 2 parts. So that fraction is 1/2. And then we have 1, 2 shaded out of 1, 2, 3, 4 parts. So that fraction is 2/4. And then we have 1, 2, 3, 4 shaded out of 1, 2, 3, 4, 5, 6, 7, 8 parts total to make up the whole. And so that fraction would be 4/8. So 1/2 is equal or equivalent to 2/4, which is equal or equivalent to 4/8, because if we look at each of our figures, we can see that they have the same amount that is shaded in each figure. So now let's look very closely at our last problem. So remember, we said that there are 3 out of 4 parts shaded. So the total is, the fraction is 3/4. What about this one? What did you get? Excellent. There are 2 out of 1, 2, 3 parts. There is 1 shaded out of 1, 2 parts, so that fraction is 1/2. There is 1, 2, 3, 4, 5 shaded out of 1, 2, 3, 4, 5, 6, so that fraction is 5/6. And then there is, and I'm just going to move this over a little bit, there is 1, 2, 3, 4, 5, 6 shaded out of 8 parts total. So we know which 2 fractions are equivalent. Well, 3/4 and 6/8 are equivalent because they have the same amount that is shaded, right? It can't be 1/2 because this one is way bigger than the others. This one looks like there's a bigger piece than this one. So we know that 3/4 and 6/8 are equivalent. Okay? So, in you checking your work, how did you do? Excellent. Isn't equivalent fractions so much fun? So, as we conclude our lesson for today, I want you to remember to use Zern and go on Reflex Math every single day. Because when you use these programs, it only helps you become better mathematicians. So I had an excellent day of teaching and learning with you today, scholars. I hope you had fun learning all about equivalent fractions. And I want you to continue being the bright, smart, beautiful scholars that you are. And Miss Dennis will see you tomorrow for another exciting day of Peak Flicks Math. Okay? Have an excellent day, and I'll see you tomorrow. Bye.